derivatives of exponential and logarithmic functions. All right, so let's start with some natural logs. So there are two rules we want to remember. So rule number one, y equal to ln of x. When we take the dy dx is simply equal to 1 over x. Since number two, rule number two is same as number one, it's just with the chain rule. So if y equal to ln of u, so dy dx equal to 1 over u, then take the derivative of the u, which is du dx. So let's apply that to some examples. So example one, if we have a function f of x equal to ln of x to the cube, so to take the derivative of that function will be 1 over x cubed. Then take the derivative of this x cubed here, so times 3x squared by using chain rule. So we end up with 3x squared over x cubed and simplify down to 3 over x. Similar example, if f of x equal to ln of parentheses 5x minus 3x to the 6th power, if we take the derivative, it will equal to 1 over 5x minus 3x to the 6th power. Then take derivative of what's in here, which is 5 minus 18x to the 5th power. Simplify it together, so put everything together, it will be 5 minus 18x to the 5th power over 5x minus 3x to the 6th power. Now we can apply that to trigonometry as well. So example 3, when f of x equal to ln of cosine x, then the derivative will be 1 over cosine x. Then take the derivative of the cosine x, which is negative sine x. Then that equal to negative sine x over cosine x. And we know negative sine over cosine is tangent, so the final answer is negative tangent x. Now they apply to the second part, in case of rule number 3 and 4. If y equal to e to the x power, then dy dx simply equal to e to the x. And same thing, the chain rule applies. If y equal to e to the u, then dy dx must equal to e to the u times the derivative of this exponent here, u, so du dx. Let's look at some examples. Example 4, when f of x equal to e to the 3x, then when you take the derivative, simply equal to e to the 3x, same thing. But then take the derivative of this exponent here, which becomes 3. So the final answer is 3 times e to the 3 to the x power. We'll do one more example. F of x equal to e to the x cubed. So we're doing the same thing. When we take the derivative, it's the same as e to the x cubed. But then when you take the derivative of this x cubed here, it becomes 3x squared. So the final answer is 3x squared times e to the x cubed. All right, now let's do one real quick with trigonometry here. So f of x equal to e to the tangent of x. Then derivative of the function will equal to e to the tangent x. Then the derivative of the tangent x, which is secant square x. So the final answer is secant square x times e to the tangent x power. All right, next set of rule is for log with any base a. So if y equal to log base a of x, then the dy dx equal to 1 over x ln of a. So if applying the chain rule to this rule number 5 here, then chain rule will be log base a of u. When you take the dy dx, it will be 1 over u of ln of a times the u right here, the du dx of it. Let's apply to an example. So if you have a f of x equal to log base 10 of x, then the derivative will be 1 over, take this x to the front, x times ln of 10. Now times the derivative of x, which is just 1, so that's the final answer. Versus if you look at the next example where, here we go, let's try this one. So if f of x equal to log base 8 of parentheses x squared plus x, then the derivative is just 1 over, then we take this polynomial, x squared plus x and ln of the base 8 times the derivative of this polynomial here, which is what? 2x plus 1. So when you combine them together, the answer is 2x plus 1 over x squared plus x times ln of 8. Okay, same thing here. Okay, so f of x equal to log base e of x, then the derivative will be 1 over x ln of e, and we know ln of e is just equal to 1, so answer is 1 over x. Okay, next set of rule, exponential. If y equal to some kind of power, some kind of base to the x power, then dy dx will be a to the x, is the same thing, but ln of a. If we apply chain rule to this rule, it will be y equal to a to the u, dy dx equal to a to the u times ln of a times du dx. Let's put this in practice here. If f of x equal to 3 to the x power, then f prime of x, the derivative, will equal to 3 to the x times ln of 3. Let's do something a little more complicated. Oops. So if f of x equal to a to the 4x to the 5th power, okay, so you have this whole 4x to the 5th power is the exponent. Then when you take the derivative, you have pretty much the same thing. But then ln of a times the derivative of this exponent, which is what, 20x to the 4th power. All right, so we can apply this to obviously to trig as well. If f of x equal to pi to the sine x power, then the derivative will equal to pi to the sine x power times ln of pi times the derivative of the sine x, which become cosine x.